Hopefully lunch was okay. Right. Can everyone hear me? All right, great. All right, my name is John Starkar. I'm a solutions architect at Booz Allen. This is Will Patterson, Drupal developer at Booz Allen. So we're here to talk a little bit about Drupal and container orchestration and all of that stuff. Like, what does it mean? Why do we care about it? They talked about it for a long time at the keynote today, so just want to keep on building off those ideas. So we're primarily focusing on this tool called Kubernetes. And the reason we kind of came up to using this tool, we had things containerized, it was great, but then we had Drupal running in the containers, and we had these other applications, and those applications were talking to each other, and how do they talk to each other, how do we manage the deployments, all this kind of stuff, and it just got complicated. And there's this tool, Kubernetes, that if you use it, makes your life easier, well, hopefully easier, and hopefully magically do things. But before we get into Kubernetes and container orchestration, since we're talking about containers, I kind of first wanted to spend a little bit of time talking about Docker. With a quick show of hands, who here is familiar with Docker, using Docker and all that kind of stuff? Great. So I can kind of go quickly through the slide, right? Docker is great. It makes makes DevOps kind of really be DevOps. You have your code, it gets packaged up into a container, it goes out, and you kind of get that whole DevOps flow going. It makes security better. Each container is running in its own little section. You don't have to worry about one application overriding another one. It's all nice self-contained things. You can also run all sorts of stuff. We have applications that are written in Python, Java, PHP, Drupal, obviously, Node, you name it. Don't know why we have all of these, but they're all there. You can throw all of them into containers, and they'll all run. They can all run on the same VM across multiple VMs. It's great. And finally, reduces the amount of time we stay at work on the machine. As developers, you've written something, works great on your local, goes out to prod. Whole thing crashes and burns. Everyone points fingers. There's yelling, screaming, all that kind of stuff. Avoid that. And so, great. Docker is fantastic. But what doesn't Docker do, and what does Kubernetes do that helps on top of Docker? So, little blurb that they say, Kubernetes is an open source project from Google for automating the deployment, scaling, and management of containerized applications. Wonderful. Here are a couple of key points that Kubernetes does that makes things better. It improves the reliability of application. So, once you have your containers out there running in your production system, how do you monitor them? Like, what happens if, a container dies, your application starts spitting out 500 errors? Like, what do you do? Kubernetes is always tracking it, trying to make sure that stuff is running and, works great. Traffic starts increasing on your site. How do you start putting out new copies of your container? How do you scale it? Kubernetes handles all of that for you. Same thing. Since it's doing the scaling up, scales down, it'll run different containers on the same VM. It handles all that logic for you. So you can have a more efficient use of your infrastructure. So less resources, your cloud budget goes down, all that kind of stuff. Saves you money. So it'll also try to figure out what VMs are best suited for running each of your containers. So, you have this machine here that has tons of cores that would be great for a database. This one here is lots of RAM, great for a Memcache or Redis. This one's great for Drupal. It figures that out and will deploy your containers to the right places. And on top of that, if you have all these different applications that are all running, talking to each other, doing X, Y, Z things, how do they talk to each other? They're going to be running on different VMs at different times of the day, or, how do you track all of that? Kubernetes handles all of that for you. And then deployments. If you need to roll out new versions of your pods and containers, it manages everything for you with just a couple of simple command line options. So, sounds great. Well, hopefully it sounds great to you all so far. Hopefully it's the case that it's not the worst thing in the world. So, I'm going to go into a little bit about how Kubernetes works and kind of how you would organize your system to use it. And then Will's going to go into some really Drupal-specific examples and a lot of the things that will hopefully help a lot of y'all out today. So we will start with the core of Kubernetes, and that's the pod. So the pod is the central component of Kubernetes. Generally speaking, it's a one-to-one relationship between a Docker container and a Kubernetes pod. One pod wraps one container. You could sometimes have some special cases where you have a container, a pod that runs multiple containers, a sidecar to enhance your original pod, but generally speaking, one-to-one, and it's controlled by your Kubernetes master. And then, it's a bit abbreviated. A couple of the metadata elements and stuff are missing, but this is it. This is your YAML file that describes a pod. It just says, hey, it's running this container, name's Drupal, it's coming from this Docker registry, and it pulls the container and the version number. And Kubernetes takes it, runs it, and you have a pod out there and running. Easy. So once you have a pod, there's all sorts of stuff Kubernetes now knows about pods and can do with pods. So it handles your system performance. It's checking to see the CPU load, how much CPU a pod is taking up, if it's getting overwhelmed. If it is, it'll start adding new pods to your Kubernetes cluster. And it just has to do that because it's just throwing out new copies of your container. And then the master's always checking each of your pods, doing health checks. You describe what the health check is, what makes it good. And if it's healthy, great. If it's not, Kubernetes will actually take the pod out and then stick in a new version into your cluster, and nothing else. It's like everything works great. And it's kind of a two-edged sword. Your system always stays up and running, which is great. But I've written code where I've done some really bad things and terrible things, and my pod is actually crashing like every 10, 15 minutes. Kubernetes is actually taking it out, putting a fresh one in, and the whole system's running fine. I have no idea. Fantastic. But so you do have a couple of things to watch out there, but Kubernetes will always make sure things are running. So that's what's great. And then deployments. You can deploy new versions of your container, and Kubernetes makes it easy. It just throws out a new pod, and it's running version 2 of my Drupal container, and it's fine. It's out there running side by side, and Kubernetes will control the traffic to decide when it should go to version 1, when it should go to version 2, and you have all of these deployment strategies that are just built into Kubernetes. You can do blue-green deployments. So you have everything running version 1, and then it'll deploy a whole set out version 2. And once every single version 2 pod is up and running and reporting healthy, it'll immediately switch your traffic over. And then you're running version 2. Or it can do rolling deployments depending on, it'll get one pod healthy, up and running, and replace one. And so you can do it gradually, which will let, some sort of canary sort of testing happen as well. So all of these strategies are built into Kubernetes. So there's a lot of flexibility for your deployments and management of all your pods. So pods are great, but as another application or a person using your system, I don't want to talk to pods. I don't want to have to keep track of where each pod is or what version it's running or whatever else. So it has this concept of services. And the Kubernetes service is really the key component that ties all your pods together. So it's just basically the external view of all the pods. If I want to talk to Drupal, I just say, hey, Drupal service, give me this page, or do whatever. And the service looks at it, says, okay, this is the version you need to talk to. It'll behind the scenes send the traffic to the right pod, get the information back, spit it back to you. And the service can do all sorts of stuff, like load balancing, or if there's an unhealthy pod, it doesn't send traffic to that one until there's something healthy, so you never see errors coming back. And then, it manages the traffic during deployment, so the right stuff goes to the right place. So services are your friend. And then same thing, the YAML file, basic YAML file, relatively simple, straightforward, right? You have your service name, we have Drupal listening on port 80, and it's a load balance service. Simple, right? It's not too big of a deal. So now that we have these pods and services, that whole concept can really just scale up and up and up to the entire size of your application. There's really no limit to the number of services or pods that you can have in a cluster. So, this little example, I have Drupal and Redis running as two different services. So here, we come in the case where you have, let's say Drupal, wants to access something from your Redis cache. It doesn't need to specify the Redis domain name or server or anything else. In your Drupal code, you just simply say, hey, Redis, cache this, or give it to your Redis configuration, and Kubernetes will send the traffic to the right place. And it's great, it works. Just in our web server configs, Drupal configs, and your applications, it's just give it the service name, and Kubernetes will tie everything together. So it's a service discovery that makes having hundreds of services in your application easy, not that difficult. And same thing, there's all sorts of different types of services you can have. You can have services that are running in your cluster. You can have a service that's actually defined to be an external service so that you can tie in stuff that isn't necessarily running in your cluster, but tie it into your system as a whole. So services really make things easy and great for your cluster. Now, we've been talking a lot about Kubernetes managing where your pods run and load balancing and all that kind of stuff, but we really haven't talked about how all of this is done on your infrastructure. Because this is part of the DevOps little talk. That infrastructure happens to be there. We try to automate it, try to make it as magically easy as possible, but at the end, it's somewhere in there. So the really nice thing about Kubernetes is it does almost all of the infrastructure management for you. Like, you have Kubernetes out there running on GCE, AWS, Azure. They have first-party support for Kubernetes. So if you tell the service that I want it to be a load balancer service, Kubernetes behind the scenes will use the Azure API, AWS API, create the proper load balancer, tie it into your infrastructure, and all that stuff is there and happens behind the scenes. You just don't need to necessarily worry too much about it once you have it up and running. So it's nice. You just describe everything with your YAML files, and then behind the scenes, everything will hopefully get created correctly. So now that I've said kind of the overall architecture of what a Kubernetes application is going to be like, Will's going to go into a little bit about Drupal and how we get Drupal running in Kubernetes and kind of the, I've said everything is great, but kind of the gotchas and some of the things that we had to make sure we did correctly when it comes to Drupal.
Thanks, Cheyenne. So as Cheyenne mentioned, we've spent a little bit of time talking about the Kubernetes resource model, and now we're going to look a little more in depth at what that would mean for a Drupal application if you're going to configure the Kubernetes orchestrator to manage containerized Drupal for you. So the first thing when I think about orchestration, I'm thinking about deployments. How am I going to get my code to production? How am I going to automate that process? And then once it's automated, how am I going to scale that automation to new infrastructure that I have, changes in my network, and so forth. So what we're looking at right here is a Kubernetes deployment. Cheyenne showed you a quick picture of this before. Effectively, we've taken a pod spec and wrapped it in a set of replication control and rollout management logic. So in a traditional deployment where you have a set of VMs running in prod, you're going to have to set up your new PHP code, make any changes to your Apache configuration, other services that are running. If you have changes to syslog, you have to balance each of those services to pick up their configuration. In your current system, if you're running virtual machines, you're probably out there running in Jenkins, but anytime you add a new server, you have to go modify all those scripts. Kubernetes is inherently aware of all of the infrastructure that it's running on because it's abstracted that away. To do a deployment with Kubernetes, we're going to take that little V1 at the end of the image and change it to V2 and send the new configuration up to Kubernetes, and it handles everything else automatically. it's going to automatically do a rolling deployment. Although if you want to do a blue-green, you can certainly do that. And it will send up your new container, stand down the old ones, stand up the new ones, and then switch it over in the service when it comes back up. So you don't have to worry about bouncing and patching anymore. It takes a big lift off of my shoulders. So the next thing you might be wondering is, that's great for one server, how about two? And that really is the nice part of the deployment, is it's designed to handle replication control. So you would instruct Kubernetes, I want 10 instances of Drupal running. All right, that's great. But we're kind of looking for a little more out of our cloud deployments. We want to be able to, we have our elastic load balancers, we have elastic databases. We want our applications to be elastic too. So Kubernetes introduces a resource called the horizontal pod autoscaler. A little more of a mouthful than a deployment, but this really is a lovely piece of magic from Kubernetes. Effectively, what we're going to tell it is, anytime in this example, CPU utilization goes over 50% of one of the underlying virtual machines, create another instance of my container, and keep doing that until here we're telling it to max out at 10, until hopefully it can handle the load. Kubernetes autoscalers attach to deployments, so you can see here we're targeting our Drupal deployment by name. So we'll attach to the deployment that we showed previously and scale up to 10 or down to 2, hopefully when your traffic falls. The kind of downside of the current implementation of the Kubernetes autoscaler is that it only handles CPU utilization as a targeted resource. There are some community plugins for other types of resource monitoring, like a number of inbound and outbound connections, but right now those are third party. The other downside is that this isn't 100% adopted by all of the cloud providers. So as we mentioned, Google is the primary producer of Kubernetes, and so GCE has 100% support for node autoscaling. So I think I mentioned this, but when we say pod autoscaling, we're saying you have your current cluster, and when CPU utilization reaches that max, we're going to create new copies of the pod within your current set of virtual machines. If you actually want your virtual machine set to scale, that's Google Compute Engine, or you're going to have to go get a third-party tool to integrate with AWS. But things are moving so quickly that as of last week, after we wrote this presentation, Azure went and announced that they're introducing first-party support for this feature as well, coming up in preview. So things move so quickly in open source DevOps that we're going to be seeing some really cool stuff in the future. So that's auto-scaling. We talked about sending out your code with Kubernetes, expanding it to handle traffic, but now we need to know, how are we going to let our applications, internal and external, contact our set of dynamically scheduled containers running on who knows how many virtual machines, and maybe 2 to the same virtual machine. If you're thinking about that, you may be wondering, if you have 2 copies of Drupal running on the same, not just 2 copies of Drupal, 2 copies of Apache running on the same virtual machine, that means they can't both be on port 80. So there's going to have to be some abstraction there as well. So if you've got something running on port 30,000, 30,001, how are you going to manage all of that? And that's the job of the service. So if you see the first bullet here, I've suggested that you can curl something called Drupal, which is a little silly, except that that's the name of the service that we've defined here. The Kubernetes service ties directly into Kubernetes' dynamic DNS system. So every time you define a service, Kubernetes has a DNS entry for that service name that is available to everything running inside the cluster. So if I have a real small container, say running BusyBox, to run Drupal cron every hour or so, I can call some abstract hostname like Drupal/cron.php, and Kubernetes DNS resolution will take care of that for me. We'll send that request to the correct virtual machine IP address, which I have no idea of, and to the correct port on that virtual machine so it can get to the right container on that virtual machine without me having to know anything about that, which really makes running a microservices architecture with Drupal in the cloud a bit of a dream. Moving on, external services. So an internal service that we just looked at is tied to a deployment. So you have your set of resources tied to an entry point. An external service lets you give a host name to, for example, a relational database service. When we talked before about having Elastic application and taking use of all of your cloud providers' different services, something you'll probably want to use, the first thing you do when you get to AWS or Azure is make use of their relational database service. And that's definitely the first thing we did. But once you do that, you're going to want to have a little bit of abstraction so that your Drupal service knows where to go get its connection to your relational database. Because we don't want to just run a single production environment, and because we don't want to hard code every bit of configuration into our code and then into our containers, Kubernetes provides a nice little bit of abstraction here so that we can have a different Kubernetes definition for each environment we want to define. This lets us have multiple copies of our entire cluster running in the same Kubernetes system. We haven't talked about namespaces, but if you do go to set up Kubernetes yourself, definitely take a look at that. It allows you to set up prod, pre-prod, staging, all within the same cluster, and then you would be able to make use of the external services to modify those specifically. Speaking of configuration management, there's a lot of that going on in Drupal, and I'm sure you're wondering if we don't want to be hard coding our database passwords, even if we don't mind hard coding our database driver. So I'm sure everyone here recognizes settings.php from Drupal 7, with the notable exception that we've gone ahead and swapped out anything that we consider to be sensitive or transient to the environment with a get environment call. On the left, you can see this is the same deployment spec that we've been looking at before, but we've gone and added in some environment variable definitions. What this does is this allows us to take our configuration out of our source control, out of our container repository, and put that into the orchestration. Kubernetes runs a distributed configuration database called SED in the background where it hosts all of this information in a secure fashion. So for the host name, you can see we're calling straight up MySQL service. We're hard coding that value, which we're fine hard coding it because with this external service, Kubernetes will automatically resolve MySQL service into our external domain name. So we can keep our code the same for each of our different environments. Next up, we're using this value from secret definition. Effectively what we're saying is there's another hidden Kubernetes resource called a secret that's being loaded in the background. At the time that you initialize this, you can pass in secrets to Kubernetes, which it will store in SED and load at the time that the container is initialized. So all this stuff gets stored in memory and doesn't wind up on disk. So you get the security of not having this wind up cached anywhere. All right, so we talked about managing Drupal code, we talked about deploying it, we talked about managing configuration, and the last little bit of idiosyncrasy from Drupal is uploaded files. So in a traditional virtual machine environment, you're going to have a shared network drive. Every time you have a server, you're going to go through all the process of mounting that network drive to your new piece of hardware. And this is the corollary in Kubernetes. Again, taking a look at the deployment that we've been using, we're just going to truncate all the environment variables from the last slide so we can take a look at this. We're going to mount a volume. This is pretty straightforward, what you would expect. We're going to specify a mount point, and then things get a little bit strange. Here we're going to take a look at mounting an Azure file share. This is different for every cloud provider, and frankly, it has to be. AWS has a different API than Azure, which has a different API than Google Compute Engine, and if you're running bare metal, there's a different set of plugins just for that. So we're going to have to specify what Azure is looking for to interact with their API. In this case, you would pre-create an existing file share, but that's exactly what you're looking for. You don't want this information to be transient, because I'm sure your client would love to have all their PDFs disappear when Kubernetes decides to reschedule absolutely everything. There is another type of volumes. If you wanted to set up a sort of stateful set of applications, if you want to run MySQL within Kubernetes, it's possible to have Kubernetes dynamically create different resources with specified requirements. However, that can get tricky, and you really have to do your due diligence to make sure that the cloud provider's implementation does exactly what you expect. Speaking of which, nothing is easy. We have a couple lessons learned. I'm going to toss it back to Cheyenne for that.
Great. Yeah, so, yeah, nothing's easy. Right, so all of this stuff is great. You have the YAML files. I think if you actually went and took the YAML files that we have in here, this would get you 9/10 of the way to a working Drupal install with Kubernetes. Obviously, we have some secrets commented out and hidden and things like that, but it's almost there. But that was after quite a bit of pain over the past couple of months, trying to really wrap our heads around it, and we've gotten to this. Kubernetes is very fast. It's the whole the development is very, very quick. Every 3 months, Kubernetes is coming out with a new version. And the implementations of AWS and Azure probably trail the official Kubernetes version by a couple iterations. GCE, since it is a Google cloud and it's a Google product, they're pretty much one for one, which is great and nice. So one of these things, ingress controllers, if you go read the Kubernetes documentation, they are the greatest thing since sliced bread. You create an ingress controller, and it handles a lot of these things related to services, load balancing, what's inside your infrastructure, outside your infrastructure, and it's even more magical. Unfortunately, AWS and Azure don't have full support for ingress controllers. So you would just need to, if you use that, you need to really be careful about what you're doing. Same thing, volume storage. Volumes are a very, cloud-specific solution. So you need to be really, really careful about what you're doing when it comes to storing your data and backing up your data. Now, the other bit about the infrastructure is, so Kubernetes creates all of your infrastructure for you, magically and automatically. You want a load balancer, it creates a load balancer. The thing that you have to just double check is if you've requested a piece of infrastructure, it does actually create the infrastructure that you want. One thing that we ran into when we were asking for a load balance service, it was creating every single load balance service as an external service that was available to the outside world. But we wanted a lot of things that were running internally. So, it's just you have to kind of pay attention and see what's going on there for that first look through when implementing Kubernetes. But once we understood what was going on, we just had our rules about, hey, if we write our YAML file this way, the infrastructure will get created the way we want. So there are some little things here and there that you have to pay attention to. And cluster scaling, we put that in because each cloud provider does it in a different way. GCE does it exactly built into Kubernetes. AWS, it was through a third-party plugin. Azure didn't do it. But then last week, Azure now has a first-party plugin. So it's really GCE and Azure support cluster scaling natively, third-party plugin for AWS. So at this point, they all support cluster scaling. So we should probably delete that line the next time we give this presentation. And then the open source community. The thing that's pretty awesome about Kubernetes, open source project by Google. So there's a big community around it. The if you have questions, there's lots of people there to answer it. But the other thing that's really great is Azure, AWS, and GCE all have first-party support for Kubernetes, and they all have their Kubernetes implementation open sourced. So, we're running on Azure for our system, but our entire stack is Linux and PHP, Apache, like nothing Windows-based. But if we have any questions, we post it to the Azure container service. It goes out there, they'll discuss it and say like, yes, they're very, very responsive. Now, the drawback maybe you run into a bug with the way they've implemented it. The next thing they ask is, can you fix it for us? So that's happened a couple of times, but it's open source community. Everyone's supposed to help each other. So, and yeah, it's been great, and they're always willing to take input from everyone using it to see what the services can be done better. So, those are kind of our main, lessons learned. So, hopefully we've kind of shown that Kubernetes is kind of a useful thing, helpful for y'all. So, what would you want to do to get started? The first two things are Minikube and kube control. Kube control, that needs to be your best friend, and you need to know it and learn it and love it if you're using Kubernetes. That one command line utility is what's used to control any cluster you want. Your dev to production, all done through kube control commands. Your deployments, all there. So you have Jenkins hooks into kube control and does all your deployments for you. And so you need to be comfortable with that. Now, setting up a cluster, if you have an AWS, Azure, GCE account, it's actually pretty easy. There's a, inside your dashboard, your portal, you can go and just create a cluster and just run with it. But if you want to set up something locally, Minikube is a really easy way to set up a mini Kubernetes cluster running on your local machine. So you can get that up and running, use kube control to control it, start creating YAML files, deploy Drupal out there, just get it running on a local cluster. And then once you have your YAML files running on locally, you can then just go push those out into your cloud provider of choice when you're ready, and it should mostly work. The Kubernetes docs, this Kubernetes is one example of the documentation actually being pretty thorough and good. I mean, you go there, they'll have every single last line of their YAML files, what they do, how they do it, and all that kind of stuff documented. It can be a bit overwhelming, but it's there, and it's good. And these last two are kind of things that we ran into that we ended up finding very useful. They're not built into Kubernetes, but when you have Drupal running, you could have 20 different pods of Drupal running, all doing different things, or you have other services running in your cluster. You'll have log files in lots and lots of different places. It can get confusing and overwhelming, and what does what. So FluentBit is this great little plugin that goes into your cluster. It'll grab all your logs from all of your different pods running and then feed it into a single place. We feed it into Elasticsearch, and it's there so that we can start parsing through and looking at all of our logs. And then the syslog and this is how to actually get Drupal's logs feeding into FluentBit, so everything all will magically work. And you can go to Elasticsearch and Kibana, which is, I guess, would be a whole different topic to discuss, to then start looking through and debugging what's going on. So these are 4 great bits to get started with Kubernetes and Drupal. And then, a couple other links. If you're really thinking about Kubernetes and you're looking for a nice enterprise support that has all sorts of additional features and things built in for you, OpenShift by Red Hat. So that is basically an enterprise version of Kubernetes. You take Kubernetes, then you already have Jenkins tied into it. You have all of your roles, controls, and RBAC, and automatically containerizing your applications. All these little nice things and a nice dashboard and GUI and all that kind of stuff. That's there with OpenShift. So OpenShift will do a lot of things for you and make some things easier, but the core of Kubernetes is there, open source, works great, and that's what we're using. And kops. Kops is a command line utility for setting up clusters and managing clusters relatively easily. It goes and will build out your whole infrastructure on AWS for you for Kubernetes and have it all run, and it'll do the management. So it's the command you would run before you get into kube control. So that's a useful tool. So, anyways, actually before we wrap this up, does anyone have any questions about?
So, on future deployments of the pod, how are you ensuring that, say, drush commands, updates, reverting, importing configuration, reverting features, whatever else happens when a new deployment comes out?
So that's something that you would have to tie into your Jenkins job. So as you do your deployments, you would have your update hook and whatever other whatever drush commands you'd want. Jenkins could run those for you.
So it's shelling directly into the container?
Yes. So when Jenkins does a deployment, you have an option to be able to shell directly into a container and run the commands you need in that container. But hopefully you can script that away so people won't have to sit normally. Or can you think of another?
No.
Yeah. Anything else? All right. So Will and I will be up at the, I guess Booz Allen. We'll be at the Booz Allen booth. It's over by the registration desk. If anyone has any questions or think about anything. And one last little, I guess, shameless plug before we wrap this up. We're always looking for really good Drupal developers, and anyone else wants to help us out with that or DevOps. So if you're interested to know what we do, our booth is up there. All right. Thank you.